In this video, I want to go over how to program a pocketing operation. To start, I'm going to right-click my pocket layer, select those objects. I'm going to go over to Machining Operations, and under 2-axis, I can see here the pocketing option. I wanted to point out that we're going to be going over profiling, pocketing, and engraving. Those are going to be the most common ones that we use. All of these other operations are rarely used, if ever. The one thing we might use is the facing operation. So these four really are common, and the rest almost never get used. If I select pocketing, you'll see that now there's 2 layers of tabs, and just like in the last drilling operations, we're just going to go through left to right, work our way through these tabs. If I deselect my geometry, you can see that under part regions, it's giving me each of the curves that I'm going to use. I'm going to go over to the Tool tab, and so if I look through here, we have different diameter tools for different types of material. So some of these tools, these are all tools that we physically have in stock down at the CNC machine. We don't have this many tools physically. A lot of these tools are the same tools, but the feed and speed rates change depending on the material that you're cutting. I'm going to go down here, and I want to select tools for plywood. I'll get into this in more detail later, but essentially to choose the right tool for our operation, we want to use the largest tool we can for the level of detail that we're looking to get. The settings that we use when we're programming will be based off of the diameter of the tools that we're using. So with larger tools, we'll be able to cut more material and remove more material more quickly. If we can use larger tools, that will speed up the process time. So we want to use larger tools as much as possible, and only use smaller tools when we need that level of detail to get the results that we want. If I'm looking at the text that I'm trying to pocket out here, I think the space in between these curves is about 1/2 inch. But for the level of detail that I'm looking to get, some of these radiuses are tighter than the 1/2 inch tool would allow. So I'm just going to go off of sort of a guess here, but I think the 1/4 inch tool is going to give us the best level of detail in getting into some of these tighter radiuses of the font. I'll point out quickly too that so there's mainly 2 different types of tool geometries that you'll see in here. For most of the 2-axis operations, we'll be using the flat tool geometry. There are flat and ball end tool geometries, and the round or the ball end usually will be used more often in the 3-axis programming. So we'll get into when those tools are used later. For now, so this is the second tool in my program, so I want to change the tool number to tool number 2. So I'll click Edit, Create, Tool, change the tool number, click Save Edits, click OK, OK, and there's my tool number updated. Now if I go to the feeds and speeds, you can see that the settings from our drill operation are still there. But if I click Load from Tool, that's going to load the new settings for my 1/4 inch end mill tool. And you can see that the spindle speed is now 14,500, which is a lot faster than the 3,000 RPM drill speed. And also the machine travel speed is all now 200 inches per minute, where for the drilling it was 30. So it's much faster than the drill. Moving over to the next tab, the clearance plane. Everything should be set to what we set for our drilling operation, so we shouldn't have to change anything here. I'm going to move up to the cut parameters. There's quite a bit of information here. Some of the stuff you may opt to change, but for the purposes of this tutorial, we only really need to change one setting here, and that's the step over distance. So down here in step over distance, we want to leave it on percentage of tool diameter, and we're going to set that to 50% of the tool diameter. And for now, that's the only thing we need to worry about changing. I'll move to the next tab, which is our cut levels. So this is similar to where we set the drill depth. Just like with the drill depth, we have the option, we need to say where the location of our cut geometry is. And so if you remember, I don't like these at top or at bottom designations. I prefer to say pick top. And once again, we're just going to enter in the actual thickness of our material. So the top of the material is at 0.75 inches. Next, we want to set the depth of our cut. And so in this example, we want, let's say that we want to go 1/4 inch deep. So we want to cut this text down 1/4 of an inch. So I'm going to just type in 0.25 inches, and that's going to be how deep I want to go. Under the depth control, so we can break this total depth up into a rough depth and a finished depth. In certain cases, you may want to use this finished depth, do one last pass at the very bottom. By default, it's going to put the full depth in the rough depth, and we can leave it like that. That's all we need to do for this specific operation. In the future, you may have things that you cut that you want to use the finished depth, but we don't need to worry about that for now. If we go down further, so down here we have rough depth per cut and finished depth per cut. If you remember in the drilling operation, I showed you how we can sometimes do a deep drill where we drill down 1 inch at a time and then clear the hole. The rough depth per cut is similar to that setting. So essentially, when we're cutting, we want to cut no deeper than the radius of the tool that we're using. So this depth per cut, we can use this to break up the full rough depth that we're trying to cut by the radius of the tool. So our rough depth per cut is going to be the radius of a 1/4 inch tool, which is 0.125. And so you can see that the slider moves to halfway because each pass that we make is going to be at 0.125 inches deep, and it's going to take 2 passes to get to our full depth, our total depth. If you were using a finished depth, you could also break that up further as well, and so that's why you have the finished depth per cut. But again, we don't need to worry about those settings. We can leave them at 0 for this. The rest of the settings down here you can leave at default. The next tab is entry exit. So the tools that we're using, the flat cutters, they tend to push material down towards the bottom of the cut, and that can create hot spots or burn marks in your parts. So when we start our cut, we want the tool to sort of come down at an angle along our tool path and gently enter the material. We don't want it to plunge straight down into the material and then start cutting. That plunging can leave burn marks and potentially create smoke or fire or hot spots in the material. So to assign a nice entry angle, all we need to do, if you look at the diagram, so the height here we want to change to match the cut level. So we're doing levels of 0.125. We're going to make this height match that cut level. And that's all we need to change under here. We don't need to worry about the exit motion. We can leave it at default. We do want to click this little checkbox here and say apply this entry motion at all levels, because we'll have two levels of 0.125 to get to our total depth. The next tab is advanced cut parameters. We don't have to change anything here. The last tab is sorting, and in this case I wouldn't worry about sorting because we just have the 3 letters, so there's not going to be a great deal of efficiency gained by adjusting the sorts. So really we can stop back in the entry exit tab and just click generate. And if you look at the data we're getting now, similar to the drill, we get the red lines of our travel. We're also getting some blue lines in here. So the cyan represents the center of the tool, and so you see a spacing of those lines at about 1/8 of an inch. That's our 50% step over. And so the blue lines represent the radiuses. So where the tool is traveling around more of a perfect circle, that center line turns blue. But that's normal. That's how it should look. You'll also notice these purple lines that represent the entry exit. So that's going to be our entry path, that slow approach carving down into the material. The last thing I want to talk about for pocketing is that if I double click the pocketing operation, if I go back to cut parameters, you'll notice that at the top here the stock value here is set to 0.025. And if I close that out and we go to top view, you can see that while this is 0.125 inch spacing, there's a bigger gap from the edge of the font. And the reason for that is that stock value, one, accounts for some inaccuracy in the determining the offset between these two lines for the tool path. So it's leaving a little bit of space. So the tool is not cutting exactly to the line, it's staying a little bit away from the line. So what we will normally do after our pocketing operation is then come in and do an inside and outside profiling to cut exactly to these shapes of our letters. So that's something that we'd want to go in and do after every pocketing operation if we want to get exactly to these lines. You could try changing the stock value to 0, but because this is running an algorithm, eventually things get rounded and certain things won't get cut. And I've seen inaccurate results even when setting that stock value to 0. So we always, after every pocketing operation, we want to come back through and clean up our edges with a profiling pass. And we'll get into the profiling setup in one of the next videos. That's it for this one. Thanks.